Welcome. I'm calling this video Tony Heller Under Pressure. Once again, one of his supporters challenged me that I could not possibly debunk one of his videos, the one talking about the idea that he has that it is planetary atmosphere's pressure that determines the temperature of the planet, thus undermining the whole concept of global warming from greenhouse gases. Well, there's several fallacies with that argument, and we'll get into those in a minute, but the primary one being, of course, is that the general pressure of the Earth's atmosphere hasn't changed, so that would not explain global warming even if his premise was true, which it isn't. So we're going to go through his arguments one by one and see where the truth really lies. One wonders whether pressure is beginning to get to Tony Heller. He makes several really stupid statements during this video. For example, the distance from the sun does not affect a planet's temperature. The composition of the atmosphere does not control a planet's temperature. The carbon dioxide bands in the Earth's atmosphere are saturated, so adding more will have little or no effect. Which of course contradicts his second point, but for the moment who's counting? And lastly, that atmospheric pressure is the sole determinant of a planet's temperature. So we'll take a look at each one of these in turn and see where the truth lies. Let's first deal with his argument that distance from the sun is irrelevant to determining planetary temperatures. His arguments are quite simple. That Mars, being 225 million kilometers away from the sun, is cold, whereas Jupiter, which is more than 3 times further away, is hot. Now that might be a persuasive argument if these two objects were similar, but Mars is a small rocky planet, whereas Jupiter is a huge gas giant. So the comparison is basically invalid. Now let's do this job properly, because I believe the distance from the sun is relevant because of the inverse square law. To prove this, I'm going to compare like with like by plotting the surface temperature of various objects in the solar system from their distance from the sun. Now I'm going to choose specific objects, ones that are rocky planets and moons with little or no atmosphere. We'll start with Mercury, then move on to the Moon. Mars is next. Then I choose a moon of Jupiter called Ganymede, and then a moon of Saturn called Mimas. So let's plot a curve through all of these points. I'll choose a logarithmic curve, and you can see they fit the points fairly well. Be warned though that Mars is slightly high here and is distorting the curve consequently, because it does have a thin atmosphere and it's mostly made of greenhouse gases, so that temperature is going to be high and should move down, and that will change the shape of the curve slightly. But it does still demonstrate that the distance from the sun is highly relevant in determining the planet's surface temperature. Next, let's move on to his statement that atmospheric composition is irrelevant. His proof is that Mars is cold and it has a 95% atmosphere of carbon dioxide, a greenhouse gas, and Venus is hot and it has the same percentage of carbon dioxide in the atmosphere. Now, I could equally turn this around and say, well, look, Venus is closer to the sun than Mars, and that proves that the distance from the sun is relevant. But let's not go back to that. Let's deal with the issue of the composition. Now, I believe that the composition of the atmosphere is very relevant. Let's take a look at the situation. Earth and Venus are about the same size. They get about the same amount of energy input from the sun per unit area. Although Venus is a lot closer to the sun, it has a much higher albedo, so much of that energy is reflected away, and in fact the amount of energy per square meter is almost identical between the two planets. Yet Venus is very hot at the surface, 737 degrees Kelvin, and the Earth is relatively mild at 288 degrees Kelvin. So the major difference between them is the atmospheric composition, one being a thick atmosphere full of greenhouse gases, the other one being a thin atmosphere with only trace amounts of greenhouse gases. Let's take a look at another one of his points, namely that adding more carbon dioxide cannot trap more heat because the bands in the infrared part of the spectrum are saturated. Here are the infrared bands of various greenhouse gases, and you can see the 3 saturated carbon dioxide bands are here. Let's take a look at that in more detail, and I'll include the water vapor as well for reference. Now the window that the Earth radiates is here. Somewhere between 4 microns and 20 microns. The longer wavelengths are emitted by the cooler parts of the Earth, the shorter wavelengths emitted by the warmer parts of the Earth. and in that window there are two saturated carbon dioxide bands. You'll notice there are other smaller bands that are not saturated, so they can make a difference just by themselves. But what happens to these bands when you add more carbon dioxide? So let's take a closer look at that. These are profiles of carbon dioxide bands at 4 different concentrations. The green is a low concentration where the carbon dioxide is saturated just at the peak wavelength near 15 microns. The orange and red and blue represent higher concentrations of carbon dioxide. You'll notice that as you go as far as the blue, the saturated part of the spectrum spreads to something like 14.5 to 15.5 microns. But the amount of absorption in that band range is not much greater than the original green band. And this is part of Heller's point. However, what he's ignoring is what happens out in the wings. In the original concentration, we were absorbing about 10% of the infrared at 13.5 microns, but now we're absorbing 35% of the infrared at that wavelength. 250% increase in the amount of infrared being absorbed at that wavelength. And in fact, the area under that blue curve is almost exactly twice the area under the green curve. So overall, by adding that amount of extra carbon dioxide, you're absorbing twice as much infrared as you were originally. Now you can turn that around and say, okay, let's assume that the blue line is the saturated carbon dioxide band at the surface of the Earth. As you go higher and higher in the atmosphere, there's less and less carbon dioxide, and eventually, as you go high enough, it will become unsaturated, and when it's unsaturated, adding more carbon dioxide can make a very big difference. That's also the point where heat energy can escape. So let's take a look at this. The situation is equivalent to a tank full of water. Now you have an input of water from a pipe, and there's an outflow of water, and those outflow is the same as the inflow, so the level of water in the tank remains the same. So in this case, the inflowing water is the heat energy from the sun, the outflowing water is the outflowing of infrared radiation cooling the Earth, and the level in the tank is our temperature. So let's change the situation a bit like we're doing by adding more carbon dioxide. What we're effectively doing is restricting the outflow. So now you have the same inflow as before, but not so much energy flowing out, and so naturally the level in the tank will go up, i.e. the temperature will go up. We can look at that from a carbon dioxide point of view over here on the right. The left part of this diagram shows a modest amount of carbon dioxide in the atmosphere. At the surface, that profile will be saturated, but at a certain altitude, quite high up, it will become unsaturated, and that infrared radiation can escape. But if you add more carbon dioxide, it will remain saturated at the surface. It will be saturated at the original altitude of heat loss, and the additional carbon dioxide will make the altitude of heat loss move up. So we'll be traveling more heat for longer, so the temperature of the planet will go up. So what does Heller claim drives the planet's temperature? Well, he claims it's just pressure. His so-called proof of this is quite simple. Venus has a high pressure and is hot. Earth has a moderate pressure and is warm. Mars has a low pressure and it's cold. Jupiter has a high pressure and is hot. At 8 minutes and 45 seconds into the video, he states the only reliable predictor of planetary temperature is atmospheric pressure. His proof is the bicycle pump. He says when you pump it, it compresses the air in there and it gets hotter. So higher pressure means higher temperatures. But that only works while you're still pumping. If you stop pumping, the gas cools off again. This very rosy picture rapidly breaks down, and we can show an example of that with some simple everyday cases. For example, take a gas cylinder. The pressure inside a gas cylinder is immense. So according to Heller's hypothesis, the gas in there should be warm. In fact, in the larger gas cylinders, I've calculated, according to Heller's scale, that the temperature should be 800 degrees centigrade just from the pressure. Now a gas cylinder is made of metal, and metals are good conductors. So if you find a gas cylinder that's warm, it's just radiating the heat from the pressure inside. As the pressure doesn't change, the temperature inside shouldn't change. So all you would need to do to have a source of heat would be to park one of these high pressure gas cylinders in the corner of your room, and you have a constant source of heat. In fact, you have the basis for a perpetual motion machine, which we all know is impossible. In the Earth's atmosphere it seems to work initially. If you look at the troposphere, as the pressure goes down, the temperature goes down. But as you go higher in the atmosphere, even though the pressure continues to drop, the temperature stabilizes and then increases, and then does other crazy things for the rest of the atmosphere. So all that says is that each layer of the atmosphere is controlled by a different set of processes, and pressure is not the main consideration in determining the temperature of the atmosphere. Is he being deliberately deceptive or dumb, or some combination of the two? Having seen so many of his videos, I realize that he keeps on making basic scientific errors, yet he claims to be some NASA engineer or scientist that has particular knowledge of these subjects. Yet he's making errors that are so easily checkable, even using Google would show him where he's going wrong. And it's not as though others haven't already pointed out to him what he's been doing wrong. But yet he continues to do it, so I can only assume that it's willful. He therefore makes false comparisons, as I've shown in this video. He ignores simple facts, again, that have been pointed out to him again and again over the years, but he still continues to do it. So I keep asking myself, why do people like him have to keep using these sorts of tactics if they have such a strong case? The simple answer is that they don't have a strong case, and they're making this stuff up in order to meet some political or religious or financial objective of theirs that has got nothing to do with the science of global warming. So if you see someone making similar arguments on another video or online, please post a link to this video and tell them they're talking absolute nonsense. Until next time, goodbye.